Next up, Nimrod Levy is a lead engineer at AT&T. An active community member, Nimrod has coordinated connectivity for Nanog conferences in the past, and he first spoke at the Nanog stage in 2017. We're happy to welcome him back to the stage for the third time today, presenting increasing IPv6 utilization in consumer networks. Welcome. Thank you.
Hi, thanks for having me here. So yeah, we're gonna talk about everybody's absolute favorite topic ever, IPv6, because nobody's presented about that today, maybe. So I'm not really gonna spend a lot of time on what it is, how it works, or whatever, but we're gonna talk a little bit about why we really, like for real this time, need to move to IPv6, because really. Particularly looking at consumer networks. So, I work at AT&T, so we have a lot of wireline customers, a lot of wireless customers. Eventually, we're going to have to build out some sort of CGN, whether that's NAT 444 or MAP-T or whatever really technology gets settled on. There's going to have to be someday, somewhere, we're going to do it. And the way the traffic currently sits, and we'll see some charts on some of the breakdowns. It's the scale of that CGN is going to be immense. There are going to be other networks that are going to face those same kinds of problems. So there's so much V4 out there that we're going to have to deal with. We really need to be shifting that needle more than what's been so far. So the CGN. So a lot of networks already support IPv6. We have some AT&T, Comcast, lots of service providers already support V6 all the way down to the CPE. So the networks are there. A lot of content providers already support V6. A lot of content is available over V6. So we support all the networks, I think. Not all the networks, but a lot of the networks are very much ready. So how much traffic are we really seeing in V6? I kind of broke some charts down in looking at different kinds of networks that connect to AT&T. The darker green shows the total traffic, and the lighter green overlaid is the amount of V6 traffic that AT&T is receiving from various kinds of networks. So these providers, some of them look better than others. In terms of how much V6 we see from particular networks, all the way up to over 80%, some 60%. This is a different provider that does mostly streaming video. They have a lower percentage, but not bad. Things get a little bit dicey. This particular provider has, think VMs that get spun up to support different cloud applications. So they're, much less percentage. And then these are CDN providers that don't host their own content, but distribute other folks' content. And so all of these networks, like you can see here, they have some V6. So they all support V6, but really why we're not seeing very much. This migration has been a long time coming, and we expect it's going to have this very, very long tail moving forward from V6. So again, we started looking at it. Why don't we have more V6? This number, I'm not sure I really like this number very much, mostly because I don't know exactly how they arrived at it. This says that the top 1,000 websites globally, only 28% of them have V6. I'm not sure how this number. Maybe somebody can clarify that because I didn't see it on that website. This is from the Internet Society. For example, AT&T. If you look up att.com, there's no Quad A record for it. But if you open your web browser and type att.com, you're going to get a redirect that goes to www.att.com, which is hosted by one of those CDNs that does, in fact, support IPv6. So we know we have a lot of content that's out there that supports v6. The networks support v6. Maybe there's another reason that there's not quite so much v6 traffic. And so I think that this might be part of it. This is a listing of an actual home network. The green on the left side is the list of devices that are connected to the network, and on the right column, the green indicates where it has a v6 address. There are a few devices that might not be connected at the time that I think could support v6 that aren't, but ultimately we've got 10, maybe 15 devices out of 28 that are doing v6. That's not a great number. So that kind of leads us to where we're heading with this is there's a lot, I think that there's a lot of content out there that supports v6, but is really being accessed only on v4 because of these end devices. So how do we get these end devices upgraded? Normally, we need vendors to push out software updates. We need consumers to buy additional buy new devices. Nobody likes buying new stuff that basically works. So really, how do we do this? Can we get can we incentivize the vendors to support older hardware? Can we get them to push stuff out? Can we get customers to buy new things? How do we do this? Do we just wait for stuff to age out? I don't know about you guys. I hate waiting. So we got to looking at this and thinking about the problem a little bit more. And it occurs to me that we have standards for NAT6, DNS 6.4 and NAT 6.4. So this is a standard where you can have islands of v6 only devices that can communicate with v4 only services. And the way this works is roughly the client does a DNS request. You have a modified DNS server that substitutes its own answer for the real answer, and you forward that traffic to a translator, the NAT portion of the NAT 6.4, and you repackage this v6 packet into a v4 packet, send it on its way. So you have this this end-to-end communication that between end devices that speak different protocols. So why not turn it around? Let's do NAT 4.6 and DNS 4.6. It turns out to be a little bit more complicated because in the DNS 6.4 scenario, you're able to take that IPv4 address of the real server and embed it into a v6 address. And so you get to save that state in the address itself. Clearly, you can't do that in the other direction. If we could fit a v6 address into a v4 address, we probably wouldn't have this problem. But I still think that there's some possibilities here. All right, so the flow kind of looks like this, very similar to what happens in the DNS 6.4 flow. You have an IPv4 only device, makes a DNS request, it hits the CPE, which is the DNS server anyway. And so instead of forwarding that A request out to the DNS resolver, it makes a quad A request. If it gets that quad A request back, or answer back, then it can associate that with a local only IPv4 address. We can probably use 100.64 for that and route that internally. So you build that association, you have to save that in a state table on the CPE. The CPE then replies back to the endpoint with a response to that A request. So that's kind of the DNS portion of it. Then you have the NAT portion of that. So the host sends that packet out to the gateway. It's the CPE. Routes it to the translation layer because we're already translating on that CPE anyway. And, uh, and so it looks up in the state table what v6 address goes along with this v4 destination, repackages the packet, sends it on its way, and then everything in reverse on the way back. In theory, this should work pretty well. I've had some initial conversations with folks who work on CPE, and they think that this is pretty possible. I mean, like I said, the CPE is already doing translations anyway, so this shouldn't be significantly different from the translations that it's already capable of doing. Clearly, we can break things. We're modifying packets in flight. Things are going to break. One of the big ones that we can call out immediately is DNSSEC. If you've got a client that's doing DNSSEC validation, we've modified that DNS request, or the DNS response. So this is going to fail. But realistically, these are clients that aren't supporting v6. Pretty sure the likelihood that they're going to be doing DNSSEC validation is slim to none. Another possibility is we could have some applications that might be embedding literal IP addresses in their responses. Some kind of custom application. So maybe the client makes a request out, and then somewhere in there, it can see that it's a v4 or v6 address, and it's going to say, go make your response to this other destination. And so if the server sees that that's coming from v6, then it might embed a v6 address somewhere in there. And the client obviously, because we're having this conversation, doesn't speak v6 at all. So that's going to fail. It's bad practice to be embedding those raw IPs in there anyway. You should probably be following DNS. So hopefully we won't have too many of those kinds of things. But ultimately, we're at the end of the day, if we can get some of these things implemented, then we need less CGN capacity. So so that means that the ISPs don't have to have as much built out there. We can start shuffling things over. And the other really nice thing about this is that it works. It fails back to v4, right? So if that initial DNS request never gets a quad A response, if only an A record exists, then you do your regular IPv4 routing, your regular whatever NAT translation, and then if that's just a NAT 4.4 on the CPE, then that takes place there, and that works fine. And if that happens to be, CGN, NAT 4.4.4 in the provider network or MAP-T or whatever, then that also works. It kind of fails back to that IPv4 path. It should operate very transparently to all of the customers. Where there's some caveats in there that we talked about. That there could be some others, but generally speaking, this should work really transparently to the customer. I would expect the cost of doing this over time should be much less than operating a much larger scaled CGN. The other nice thing that we can do with this is that it's not dependent on the provider network. So in my network, in AT&T's network, we control all the CPEs, we certify the software, it's our CPE, and we push out all the firmware updates. Obviously, not every provider network operates like that, but this still works independent of the provider network. So I would envision a scenario where you get your, whatever router you have, you plug it into your ISP's connection, and it detects, hey, you have a v6 address available. Would you like me to set this up to push more of your traffic over to v6? It could be a very simple solution for a customer, for an end user to do. They don't have to be, one of us that knows how BGP works and how all of these things operate. So, what do we do next? I think the next move here is to work with our CPE vendors and our partners over at different manufacturers to get this functional. See if we can make this work, and move forward from there. See from the clock, I actually ran through these slides a lot faster than I intended to. So we have plenty of time for questions, but I wanted to call out some folks that helped me a lot with refining some of these thoughts and ideas. Um, and that's kind of the end of my idea here. Any questions, conversation, anything from anybody?
Lee Howard from IPv4.global by Hilco Streambank. I can't resist talking about IPv6 at any opportunity. I think what you've described is fairly similar to the CLAT function in 464 XLAT, right? Because you're translating from 4 to 6, whether or not you're translating from 6 to 4 later, which is great. What I'm hearing from ISPs around the world, generally smaller companies, is that they can't deploy IPv6 or they can't save on IPv4 addresses because they can't get vendor support in the CPE, whether it's v6 support or 464 XLAT support or MAPT support, whatever transition mechanism they're looking for. And I've been trying to find a way to get to more of those vendors because, of course, a lot of the CPE vendors are repackaging OpenWRT or equivalent, and the packages exist. You just have to, install the package and turn on the button. But if you don't control the CPE, then you can't even get that done. So I'm still, you're right. You're absolutely right. The next step to do that would be to talk to the CPE vendors, and I've been having a really hard time getting in front of the CPE vendors.
Yeah, thanks for the comment. That's I think that's great. If some of us as providers that do control the CPE, if we can start pushing some of these things in as standard functions, then I would hope that they would become more available, generally in other networks that maybe aren't AT&T. Thanks.
Tom Strix, Cloudflare. Thanks for that talk. That's really interesting. Couple of ideas. How do you see this interacting with quite a few vendors, primarily building new features on top of IPv4 and then doing IPv6 a year or 2 years or never later when it comes to proper carrier stuff? Because at that point, you're going to do v4 on v6 on v4, potentially on MPLS.
Right. So the way I kind of see this working, it's really sort of independent of what's going on out in the carrier network. So whether you're doing a CGN or a MAPT or whatever you're doing, you're kind of distributing this translation layer down to the CPE. So it can operate completely independently at that level, pushing the traffic to v6, provided the applications are properly performing DNS lookups and using the DNS to distribute the host names. But then if there's still things that really are only on v4 and don't have the quad A records, then it just follows the regular v4 patterns. So I don't really see any conflict there, as far as I can tell. But hoping I could be wrong, maybe. Yeah.
An additional question then on top of
Please.
that. How do you see that interact with Happy Eyeballs?
So the target for this this transition mechanism is really for devices that don't support v6 at all, right? So there's no Happy Eyeballs in that equation, I think.
Lee Howard again. Since there's nobody else at the mic, I thought I'd also ask you. One of your points that was that CGN there may be a performance difference introduced by CGN if you're doing a NAT4.4 CGN, but you're doing v6 natively, and that will be an incentive for other folks to deploy v6, which would be great. My testing, which is a few years old now, hasn't seen any measurable latency through CGN.
Mm-hmm.
It was sub-millisecond, so we can't count it.
Okay.
Have you seen?
No, I don't have any hard numbers on that, but we would hope that would help. Just even the idea of that, right?
Right.
That you don't want your traffic to be going through the CGN, so let's do it the other way.
There's lots of other reasons to not like CGN. Like you want to do RBLs, or you want to do geolocation, or you need to do some kind of reputation or other information based on IP address. And
Yep.
Geez, suddenly you've got shared fate. There's reasons to not like that. But yeah, that particular one, oh, geez, maybe you've got data that I
It's a
hadn't.
fair point. Yep, absolutely.
Philip Simons, Network to Code. I've worked with quite a bit of enterprise environments. And in the enterprise, there's not a ton of like pressure business use case to deploy both stacks because then you have to manage a second stack. And there are security implications to not wrestling with it, but most enterprises just don't wrestle with it. I like the idea of putting back pressure onto the client side to say, hey, use IPv6 because otherwise your connections are going to degrade when you're going through CGN instead of just going directly to whatever your server is. Do you have any other ideas at putting some gentle back pressure to kind of like force enterprises to think about and reconcile that and make it a valid business use case where they favor IPv6?
Yeah, I mean, enterprise is, as you point out, a very, very different beast. You know, they can run their own little walled garden, whatever they want inside, and and then a lot of enterprises, you know, will carefully control what goes in and out. So, you know, it's a lot simpler, I think, for an enterprise to just, you know, slap a proxy that is v6 enabled or, you know, whatever their application might be on their border. And they can, you know, I'm happy to let them do whatever they want internally. But clearly, at some point, they're going to be, there's going to be a need for them to talk v6 externally, which is, you know, kind of a different problem. But I'm not sure I really have any other ideas at the moment for pushing enterprises in that direction. It's a tough nut to crack.
Thank you.
Thanks. Anything else? Anybody else on the web? Anybody? Great. Thank you very much for your time.